There's never been a better time to have SiriusXM. With over 140 channels in your vehicle, your all-access trial includes more than ever before to enjoy online, on your phone, or at home. Create your own ad-free personalized stations powered by Pandora. Hear ad-free extra channels and enjoy favorite shows with SiriusXM Video on Demand. What you love is on now.
Hey guys, thanks for tuning in to yet another CMA Connected Lunchtime Learning Session. I'm your host, Ben Wu, and this session, of course, is brought to you by SiriusXM. All right, so today's guest and today's distributor, of course, is Gemsen, as you've read in the description. And, of course, Gemsen's been with us multiple occasions, and joining us today will be none other than Dave Singh from Gemsen. But let me set you up a little bit. This might not be what you expect. You know, Gemsen's got a lot of premium brands, and when it comes to Kicker, you know, we always love having the guys at Kicker on because they've got that one heck of a setup with their, you know, their entire unmasked studio. But today, we're not going to be talking about sub boxes. Heck, we're not even talking about passive radiators. We're going to be talking about something that maybe you didn't give as much thought as you should be giving towards. Let's go ahead and bring on Dave, and maybe he can shed some light as to why he decided that today we need to learn more about wiring. What's going on, Dave?
Hey, Ben. Good to see you.
You heard my intro. It wasn't what I expected when I seen that email come through, and you're like, Ben, this is a Kicker. I thought, you know, standard issue. Let's bring on the Kicker boys. Let's get loud, right? But now we're talking about wiring. What's going on?
Certainly, you know, when it comes to Kicker, you know, the things that people really come to think about Kicker is subwoofers, amplifiers, speakers. But you know, wiring isn't one of the things that Kicker's most well known for, and that's unfortunate because they have such a huge selection of wiring. And you know, the reason why we decided to focus on wiring today is it's one of those categories that people look at as an accessory, and I think that's a really bad word for it. You know, wiring does consist of cabling, you know, RCA cables, distribution blocks, fusing, and maybe that's the reason why they call it an accessory. But it's one of the most important parts of the system design, and it can really make or break your system. You know, poor wiring can really have an adverse effect on the performance of your amplifier and reliability. And, you know, good quality product will ensure that you're getting the most performance out of your amplifier that you paid good money for.
I gotta say, you are preaching to the choir here, son, because I've always been an advocate of you know, being aware that your system is only as strong as its weakest link, and every component of that system affects the final result. Having said that, if I know the guys at Kicker and the team at Kicker, they don't do anything half, you know what. So I'm pretty excited because I've seen some, you know, I did a little bit of research before the show. Man, these guys take it real serious. I mean, really serious. Like Kip does stuff like live. I'm not going to give it away. I hope he brings it up. I'm going to drill him a little bit on what's going on. Why don't we bring him on? What do you say, Dave?
Great.
All right. So straight from the Kicker UnMasked studios, we are privileged once again to welcome Mr. Kip Litsey to CMA Connected. Welcome, Kip.
Hello, everyone. Kip Litsey coming to you live from the Kicker UnMasked Live Weekly Studios here in beautiful Stillwater, Oklahoma. Don't know what the weather's like in your neck of the woods, but it is blue skies and hot here today.
For the first time this year, I can agree. We also have blue skies, and it is hot up here, rather. Thanks for joining us, Kip.
Hey, it's our pleasure to always join you, Ben. And Dave, it's good to see you. Gemsen, you know, you guys are fantastic partners north of the border. We love having you involved with the Kicker UnMasked show, especially helping us bring winners in. And we've actually had 2 people win north of the border prizes on our Unmasked weekly, nightly show on Tuesday. So thank you for helping us do that.
Absolutely, our pleasure. Hopefully I can enter myself. Maybe I might win some good swag. And,
if you let Dave enter, I'm entering. You better be careful what you say here.
There you go.
Yeah.
You know, what's that real fine print, you know, family members, members. Yeah, you disqualified yourself already.
Oh, there you go. Kip, listen, first of all, thank you for taking the time. I know with the events coming back into play, Kicker with so many activities, and man, I'm sure you guys are excited just to get on the road and share the passion, right?
You know, honestly, we are an events-based company. We're a people company. We love getting out in the field and doing live events, and we have a huge one next week, and we're in full-on mode this week getting ready for it. It's called the Kicker Country Stampede, and it's actually going to be the first major outdoor music festival in the U.S. since the entire lockdown and shutdown of COVID last year. So we are excited about it. Normally, we see about 50, 60,000 people at this event. We're getting from the promoters that we're seeing maybe 70 to 80,000 people a day at this event. It's going to be huge. People are ready to get outside. They're ready to interact, and Kicker's going to be there to do it. Now, this doesn't mean we're not going to keep doing the unmasked or the virtual stuff we're doing. This has become a fantastic tool in our tool bag, but just like you need a hammer, you also need a screwdriver, and this is just another way that we get out and talk to people and let them know what we're about and let them actually, touch and feel it. So it's going to be great. We're excited.
Well said.
As
well
you can
said.
tell.
Oh yeah, absolutely. And you know what? Please do keep doing them. They are certainly the benchmark for this type of platform. Let's switch over to Kicker DNA for a second here before we set up what we're about to learn.
Sure.
Whenever Kicker puts their engineering team or their mind or their focus on something, you guys take it pretty darn serious. I don't think anybody can argue that, whether it's, your solar barracks or when you get into power sports and marine or not motorcycle. We had Joe on, and he's super passionate. So I am very curious about how passionate is Kicker when it comes to the science of wiring.
Well, you bring that up, and, I've really got to give a shout out to Dave, and I'm going to say this, calling wiring and distribution blocks and RCAs and speaker wire an accessory to an amplifier is kind of like calling windows and doors an accessory to a house. You can't build a proper house unless you have good windows and good doors. I mean, you have a structure, but boy, it's going to be hard to heat, hard to cool, keep the critters out, and you have all the uninvited guests you want any time of the day. So it's really not an accessory. It is a component that you need to properly build an audio system, just like windows and doors are a component that you need to build a proper house. And we've really kind of twisted that on it. We're trying to get the word accessory out of our vocabulary because you can't make an amplifier work without it, just like you can't build a home without windows and doors. So that's really how we look at it. And when we got talking about this topic, really when it comes down to wire, and I'm sure Dave will probably laugh at this, there can be a lot of snake oil in the wire business. And we're not about snake oil here at Kicker. We're about science. And when it comes to wire, if we're going to be honest about it, get into the science to it, there's really only 3 things I can talk about when it comes to a wire. And I'll say 4 if I want to throw the 4th one in, but it's really, what's the resistance of the wire? What's the inductance of the wire? What's the capacitance of the wire? And last but not least, because we're dealing with cars, what's the flexibility of the wire? Because really, when you're running through a car, it's not like you're going to run 5 cm or some big, huge wiring that you normally use in a home and using a pipe bender to run that through a car. It just doesn't work. So wiring in the car has to be made very flexible. And if you're looking for long term, you want that wiring to be 100% copper. That is the best material that you can use for a power wire. And then if you say, okay, I want to use the best wire, but I also want to have some resistance to corrosion, I want resistance to salt water, I want resistance to any humidity, you want to make sure that wire is tin plated. And tin plated copper is honestly a standard that if you're making good wire, you're going to use tin plated copper. Now, how many strands of it? Are you making sure it's a true American wire gauge? How flexible is it? That all comes in the design, the twisting, the roping, and how you're going to lay your wire out. But you really want to use true gauge, 100% copper, and if you're worried about giving your customer the best performance and corrosion resistance over time, you want to make sure it's tin plated. And yeah, our wire fits that standard. So when we were discussing all this, we kind of found a way to bring it into the show. Is that what could we do live? And I know you mentioned what we do live. We do a lot of crazy things live. We let people know up front. We don't know what's going to happen. Something could break. There could be a fire. We don't know. I mean, we've done the testing in advance, and we kind of know what we're going to expect. But we do everything live because we want to have that transparency that they see everything that's going on. When we change connections, we change amps, we want there to be no question that you're looking at a demo that is 100% honest and transparent. And so we did a couple shows. We call it the Science of Wire. We did a part 1. It was so good we backed it up with a part 2. And between those 2 shows, we actually did a demo of 8 gauge, 4 gauge, and 1/0. And what we focused on is what's the key differences between a 4 gauge CCA wire, which is copper covered aluminum, and a 4 gauge 100% copper wire. And we also did the same demo with 1/0. And we came up with some creative tests, and we did those live on the air to show we really stressed the wire. We took it beyond its limits, but it was so that you could see what is the limitation of OFC wire, what is the limitation of CCA wire. And what we hope at the end of that result is that people can see that no, CCA wire is not the exact same thing at a lower price. CCA wire is lower performance at a lower price. And if that's what you're willing to do, just understand that's what you're getting into on the front side. But I can tell you, we look at the returns that come into Kicker on amplifiers, and the vast majority of amplifiers, seriously, are no trouble found. Our engineers in the back look at them, they test them, there's nothing wrong with the amp. And when we chase that trail down, we find out that the end consumer, yeah, he was having problems. The amp's shutting off or low voltage or going into protection. And then when we dig deeper, they're using either undersized wire, they're using copper-covered aluminum wire, or worse, they're using undersized copper-covered aluminum wire. And when you put those two together, you're literally starving the amplifier for current and voltage, and it's not going to perform well. So it's not just about buying copper wire. It's not just about one company trying to beat up another company on technologies. We're just looking at the science of it. You can use aluminum. You can use copper. But if you use aluminum, you got to use twice as much, almost 3 times as much to get the same current capacity as copper. And once you bring that into the equation, then it becomes, okay, did I really save any time? Because now I've got to run 3 strands of the same size to do what copper would do. Did I really save any real estate? Did I save bulk under my carpet? And more importantly, did I save time or money? And in the end, the answer to all those is no, you didn't save anything. But what you did do is put your amplifier into a situation that you're not getting all the performance you paid for. And that's why we did these 2 shows, part 1 and part 2. And they were live demos. And we'd love for your audience to see these demos. We actually have went through and cut out the meat of what was in those shows, and going over the 4-gauge wire and the 1-gauge wire. And I think when it's all said and done, the eyes of a lot of you guys watching your show are going to be opened, and they may even have a lot more questions. But the good news is all the questions are going to lead to the same answer. You should be using 100% copper wire.
The very fact that Kicker is taking the time to do this, we're going to talk about this after we watch and we learn. But just a quick a preface to what you're about to watch. This is Kip in there doing tests live. Anything could happen. But he brought in industry specialists to kind of as a witness, I guess, or, part of the party. Hi-Fi Vega's in there. Derek Williston from Williston Audio Labs is in there. So we're going to roll the tape. We're going to get our learn on, and we're going to come back and kind of just, after we marinate a little bit, I'm sure I'm going to have a question or two for you and kind of round this out to see what the takeaway is. Dave, you have anything to say before we go?
Let's get started.
All right, let's roll the tape.
Hello, everyone. So we actually set up a camera over here in the lab, and we kicked Wade out this afternoon and said, Wade, we want to commandeer your area because we want to do some interesting tests. And he said, sure. He said, I've got all my work done for the day. You guys can have the lab early. So we took it over from him. So what we've got in here, hopefully Tim will get in here. We've got a rack of Astron power supplies. There's 6 or 7. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7. So there's 350 amps of current on tap. So we have plenty of current and voltage to run this test. And what we've got on this test bench is we have a Kicker KXA 2400.1 amplifier. And as far as how it's connected right now, right here on the side of the bench, this is, and if you're not familiar with them, it's called an Anderson connector. And an Anderson connector is a very, very high current connector that you can use to plug and unplug and run huge amounts of current through them. They do it safely and effectively. So this Anderson connector right here, I think the continuous duty rating on it is either 175 or 200 amps, and then I think peak duty rating on it's over 300 amps of current. And so what it allows Wade to do on a daily basis is he can plug and unplug here whatever gauge wire he needs for whatever amplifier he's putting under test. So if he needs 8 gauge or 4 gauge or 1/0, he can change that. But what we created today, we took and did we actually have 4 sets of cables here. There's 4 sets. And we've got a run of Kicker 1/0. We have a run of Kicker 4 gauge. And then we have a run of CCA 1/0. And we have a run of CCA 4 gauge. And the brand of the CCA, I'm not going to tell you, don't even ask because it doesn't matter. We're not talking brand to brand. We're talking 100% copper wire versus a CCA wire. That's all this comparison is about, and I will never ever tell you the brand of wire because it doesn't matter. We snake skinned it so you can't even see the brand name because it doesn't matter. We're talking about the technology, not the company or the brand behind it who's selling it. So the first test we've got here, we really wanted to come up with a stress test to show you the limitations of copper and the limitations of CCA wire. So what I'm about to show you, understand this is not what we recommend for anyone out there to do. If you buy or have a Kicker KXA 2400.1 amplifier, we 100% suggest you use 1/0 wire. What we wanted to do here is we wanted to stress the wire so that you could see the differences between copper and the differences between CCA. So what we've got here is from the Anderson connector. It's a 20-foot run of positive and a 20-foot run of negative. So there's 20 feet of each, and that's to simulate the length that you would have in an extreme car in today's world. Sometimes you got to run across the firewall, down, and back across the back, and in those cases you can't get into the 17 to 20-foot run of wire that you need. And in a lot of new cars today, they're not welded anymore. They are glued together. So finding a good, solid place for ground can be very difficult. Most anyone you talk to tells you, whatever size power wire you're running back, just go ahead and run the same size ground and ground it at the battery or ground it at the alternator. You know, do the big 3 upgrades so that you've got a good solid power source up front between your engine, your alternator, your battery, and your chassis. So running your own ground wire is not uncommon. Matter of fact, in boats, Corvettes, anything with fiberglass, you have to do that because there's no real chassis to ground to. So this simulates doing that, running 20 foot of power wire back and then 20 foot of ground wire back, because you got to get back to the battery instead of the same gauge. So the first test we're going to do is on the Kicker 4 gauge. And so we got the amplifier here set up. It's through an Anderson connector. We have plenty of current. We have a tone generator right here, and this generator is going to create a 50 hertz sine wave, the same frequency we're using out in that portable display you saw over in the studio. This is just more of a lab grade version sitting here on the top, but this is a 50 hertz tone generator. We're sending that signal down into the amplifier, and then we are reading, and this I got to give a shout out to our good friend Steve Mead out at SMD, Steve Mead Designs. I reached out to him and said, hey man, I need to get a meter from you. We got some testing we want to do coming up and some other in the future, and Steve worked with us, and basically he just sent us the meter to use. So I'm going to give a big shout out to Steve Mead, man. Thank you for getting us this tool to use in the Unmasked Live studios. We're going to be using this tool a lot in the future, and we can't thank you enough for working with us on this. So thank you, Steve. I have to say that. So there's my shameless plug for Steve. He's a great guy. So what we got is this amp hooked up to the 4 gauge. We have an SMD AMM1 amp dyno meter, and it's going to measure what's the power coming out of this amplifier. Well, what's the amplifier driving? Well, over here underneath this test bench, we've got great big silver 1,000-watt dummy loads, and that's what these plugs right here on the bench are for, these red plugs. I'm actually plugged into the dummy loads that are underneath the bench here, and so these come up and they plug into the amplifier. I will say this. We did several runs of this afternoon so that we could test everything. What we're about to do is the absolute hardest test you can put an amplifier under, any amplifier, it doesn't matter. We are running a continuous sine wave with no duty cycle. It's on. We're running the amplifier to full output clipping. We are doing it into a fixed 2 ohm resistive load bank. We didn't smoke an amplifier, but it's entirely possible that on Unmasked Live tonight, you may see us smoke an amplifier. And if we do, we've got a backup sitting here, and then if we smoke it, we'll get them both fixed tomorrow because we know people back in repair. But this test we're about to do is the hardest test you can put any amplifier through. A speaker load is a reactive load that the impedance is constantly changing, and actually the impedance rises on the speaker. So even if you wire it to 2 ohms, it's not playing at 2 ohms all the time. It's actually playing up and down, and that impedance is moving based on frequency. Okay, this is a fixed resistive load. This is the hardest test on an amplifier. So we're letting you know up front that if we smoke an amp, we know it's entirely possible because this test is hard. We also know we design our amps to pass this test, so we feel pretty confident we're not going to have a problem, but just in case, we're ready. So I'm going to go ahead and fire up the meter here. And if you got anything to add, Rob, please feel free to chime in.
Oh, I can just confirm that this is a very hard test. This is the test that me and Derek both run. And the 1 kilohertz is much easier. 40, 50 hertz, that is absolute torture on a sine wave, on a pure resistive load. It's murder on your amp, and that's why you often see Derek running dual 1/0 power runs to it to just kind of alleviate that. And, you know, running a 4 gauge power wires at 20 foot on the power and ground is a bit sketchy. It is very sketchy. I'll confirm that.
It is a bit sketchy. So what we're going to do here, I'm starting with the amplifier gain turned all the way down, and I'm going to go ahead and turn on my signal. So now I've got a 50 hertz signal being fed into my amplifier. I'm going to fire the amplifier up. let it come on. There's the light. That tells me I've got signal. We're good to go. And then I'm going to rely on my boy Timmy here, and I can see he's got a good picture on that. So I'm going to bring the amplifier up to clipping. So I'm just going to bring the gain up.
Yeah, give it the beans.
I'm gonna pour the gravy on hard. So I'm going to keep going here. I'm going to take it just a little bit. I'm at 1%. I'm going to take it a little bit higher than 1%. Should be right about 1%. So right there, you can see, I don't want to get in the way of the scope, but you can see we're putting in at about 2385 to 2442. It's fluctuating in between the high 2300s to mid 2400s, and we are into a 2 ohm load. That's what you can see on that SMD amp dyno. And the voltage over here, you can see we're at 13.15, it's fluctuating just about 13.1 to 13.15 voltage. And we are starting with right about 14 coming out of the power supply. So through that 40-foot run, because it's power and ground, you can see we're getting about a volt drop, but our amplifier is still producing well over 2,400 watts. It's definitely making rated power. And the wire itself, it's getting warm, but it's not. Now understand, this is a stress test for 4-gauge on this big of an amplifier. This is absolutely a stress test.
And this is a
right
very,
there,
the amp's very efficient. I know this amp's very efficient, but I'm sure you're still pulling over 200 amps here.
Oh, yeah, easily. The wire right now, I'm reading on the positive wire with my meter, I'm up to 95.5 degrees. It's fluctuating between 94 and 95. There's a 96, 97. There's 99. It's now getting up to 103. Let me touch it. Yeah, the wire is getting warm. And I'd expect the wire to get warm because I am pulling way more current over this 4-gauge wire than is recommended. I mean, we are way beyond spec as far as what we should be doing here. But what I wanted to show is the amplifier staying on. We've been running it. It's still putting out 2,500 watts. It's at 2,500 watts now, 2476, 2,500. The voltage is dropping, so now you're seeing our semi-regulated power supply kick in, and it's maintaining power. And we're seeing 12.68 volts now coming from the bank over there. And that is because we are starting to heat this wire up, and we're starting to see some loss through the wire. Right now, I'm up to 116, 117, 118. Take another reading up here. There's 119. So the wire is getting warm. I mean, it's definitely warm to the touch, but 4-gauge is running this Kicker amplifier to full 2,500 watt output. Now I'm going to go ahead and turn the gain back down. And hopefully everyone was able to see that on camera. What I'm going to do at this point, I'm going to shut the amplifier off. And what we're going to do, and we're going to do it live here on camera, so you get to see the monkeys and the football having fun here. But we're going to disconnect the power and ground wire from the amplifier. We're going to unplug this Anderson connector, and then we're going to plug in an Anderson connector that has 20 feet of power and 20 feet of ground with 4-gauge CCA, and we're going to do the exact same test and let you see what happens there. So try to keep yourself entertained. Robert, if you got some things you want to ask or questions of the audience, I'm going to go ahead and do this live because I want people to know this is actually what we're doing.
Well, you know, Derek said here it's crazy that amp was doing its continuous rated power for that long on 4-gauge wire. That's
yes.
You know, wire aside, that's pretty impressive for that amp to begin with. And that was a couple minutes.
Yeah,
continuous
easily.
full on a sine wave. That speaks volumes to the amp. You know, just straight up. And I'm afraid how hot this 4-gauge CCA wire is going to get. And Kip said, you said you would not tell him the name of it. I'm here to tell him this is Hi-Fi Vega branded CCA wire. He had me send it to him last week. It's up there. He went ahead and put the skin on. I told him he didn't have to, but.
I love it. That's awesome, man. Thanks. And that's the thing is I want people to understand is, you know, yeah, we're Kicker, and yes, we sell products and we make products, and we love that people have great experience with our products, and we want to sell gear for people to enjoy their life and their music and where they want to take it. Absolutely. But, you know, Unmasked Live isn't just about Kicker gear. We really want to give people the science of things. We want people to understand what they're getting into. And this is, when it comes to power wire, if you don't use 100% copper, the only person you're cheating is yourself. Yeah, you're saving a little bit of money in your wallet initially, but you're not getting the full performance out of your amplifier. And if you're using wire that is not giving you all the current you need, you are definitely current starving your amplifier. And we have the data that proves it. Is when people send in amplifiers and our guys look at them and they figure out, you know, what is it? Is it blown FETs? Is it a power transformer? You know, what's going on with this amp? Why did it die? And then they get on, in a lot of cases that are extreme cases, they'll actually get on the phone and get with the customer or the dealer and, get more details. Well, what was this hooked up with? How was it hooked up? Why? And they'll find out that in a lot of cases, it's inferior wire. It's either CCA wire, which is a no-no, or it's not true spec wire. And that's the other thing you got to be careful of is, on one hand, we're telling you, just use 100% copper. But the other thing you got to be careful for is there is undersized copper that it on the outside, the jacket, it appears to be a 4-gauge or a 1/0 wire, but when you actually look at the amount of copper that's inside, you're paying for insulation, you're not paying for copper. And insulation doesn't carry current. So gauge matters, true spec matters, and 100% copper matters. When it comes to the amount of current and things we're doing with an amplifier, it all matters.
And that's exactly why I started testing 1/0 OFC wire, because of this. Unlike, welding cable is all, held to American wire standard for the most part. But in car audio, you can get a mixed bag. You can get a very thick jacket that they're calling 4-gauge. So you've got to get it from a reputable company for sure.
Yes, you do. And again, the last thing I want us to advocate on our show, even though it's Kicker Unmasked Live, we're not advocating any brand over another brand. We're advocating technologies. Yes, our wire is 100% copper. Yes, our wire is true American wire gauge. Yes, our wire is tin plated, so you don't have to worry about corrosion. Those are all great things about our wire, and I'm going to proudly say that. But at the end of the day, if you got a budget to hit and a Kicker wire kit's just not in the cards for you, and you can find a true spec 100% copper gauge wire kit from someone else that does hit your budget, I'm going to tell you to buy that every day, because you are always going to be better off for the performance of your system and your money spent to use the right materials, even if it's not Kicker.
So what you're telling the chat?
Sure. Go ahead.
I was going to say, so what you're telling the chat is that you won't be mad at them if they use CCA, but you will be disappointed in them.
I will be disappointed in them, and if they start having the conversation about performance or warranty issues, that's going to be my first question. It's going to be our warranty department's first question, because wire matters. Wire is not an accessory. Wire is a component. And you, just like the quality of your amp and the quality of your speakers and everything else, wire is a component that will make or break the performance of your system. Dabaday here, he says, is the wire casing melting point the same on CCA as on OFC? Dabaday, that's a good question. Don't know. It really depends on the manufacturer and what they've specified. Could you have CCA wire and copper wire that has the exact same insulation that's made to the same standard? You absolutely could. Can I tell you they are? I absolutely can't. I don't know what the melting points of everyone's jacket is, whether it's CCA wire or 100% oxygen-free copper. But is it possible that they're the same insulation? Yes, it is possible. Is it possible they're not? That is as well. So I can't answer that question for you directly. That would really have to be a manufacturer's question where they give you the breakdown or the MS, my brain just locked up on me, the material safety
MSDS.
data sheet, MSD. Yeah, that's exactly where I was going with that. Is if you got the MSDS sheet, it would tell you everything, the composition of the jacket, the melting point, the flame point, all that information would be there. So I do not and cannot speak for any other company, and I cannot and will not say that their insulations are different between OFC and CCA. It could be and it could not be, but that's a great question, and you should be asking the manufacturer that question if it concerns you. So great question. Thanks for bringing that up. So I've got our amp hooked back up, at least it looks like I do. I think I got all my ducks in a row here. And so what we've got here, and I got to turn the SMD meter back on, so just work with me here.
I'm a little nervous.
We apologize that it's a little clunky here, but we wanted to do this live.
I'm nervous. I don't know what's going to happen here. This is now we were kind of sketchy on the 4-gauge OFC, so now we're extreme sketch mode. Did you test this earlier?
Yes, I did.
Okay.
And you're correct. This is extreme sketch mode. Are you ready?
Yeah, let's go, man. This is what I live for.
All right. Okay, so I'm going to fire the amplifier back up. Timmy's over on camera, so hopefully he's getting everything into the picture he needs to get. I'm just here to tell you what's going on. Fire, fire, fire. So you can see we got 14.4 volts starting out, and that's at the amplifier here. That's what this meter is reading, is what's the voltage at the amplifier. I've got my test tone on, 50 hertz. We're now going through the same scenario, 20 feet of power, 20 feet of ground, except this is CCA. So here we go. I'm going to start cranking it up. And the amplifier just turned off. And I'm going to turn it back down. And well, this is what's cool about it. I'm gonna try. I gotta run the gain knob up slowly. So what's happening is the CCA wire.
So it's taken to low voltage protection.
Exactly. And so what's happening, if you can see on the meter, we're only at 1,400 watts of output. So we're 1,100 watts less than the previous wire, which was the solid copper, and I've already dropped to 13.6 volt, and I'm just gonna keep tweaking the knob up a little bit, try to get a little bit more out of here. There's 1,700, there's 1,800, we're down to 13.1 volts. I'm gonna keep tweaking up a little bit more. There's 1,800 watts, 1,900 watts. Voltage sagged so low that the amplifier went into low voltage protection mode. So I'm going to turn the gain back down just a little bit so it'll come on and stay on. So there's 1,240 watts. So what you're seeing here is the same gauge wire, simply 4-gauge copper versus 4-gauge CCA. I can't even get the Kicker amplifier to full rated output over CCA. So what are you seeing happen here? Again, as I said in the beginning of the test, we are stressing the wire. 4-gauge wire is not designed to run this big of an amplifier, but this is what allows us to show you the limitations of CCA versus 100% copper. And what you're seeing is on the 100% copper, we were able to make 2,500 watts, no problem. Here, I'm idling at 1310 and it's staying on. The most I was able to get it to this afternoon was 1,800 before it would shut off, because as the amplifier is trying to make more than 1,800 watts, it can't, because it cannot get the voltage and current it wants through that wire. It's just not capable. So I've got there, it's 1966. It peaked there a little bit. I'm going to turn it back down just a little bit more.
Well, Andy had a good comment. He said, this is a great video for the people that ask, why does my amp keep shutting off when the bass hits? This is why.
Bingo. And you know, I got to tell you, and thanks Andy for saying that. Guys, I can't tell you how many times our techs in customer service or our amp repair guys in the back, when we trace down the problem to what the customer's experiencing, 9 times out of 10, it's wiring or connections. Poor connections, like you said, Robert, and I can't stress that enough. I know you and I have both seen how many melted fuse holders and melted terminals because they weren't crimped properly, they weren't tight, and those loose connections or bad connections cause lots of heat, lots of melting, and current starve the amplifier, which causes the electronics to go bad prematurely. And also, from a guy called up, man, my amp, every time the bass hit, my amp shut off. Or at night, every time my amp hits, the bass shuts off, but during the day, it plays okay. Well, at night you got your headlights on and you might have your defroster on and all these other things drawing power in your car. There's not enough voltage and current after the loss through undersized wire or CCA wire for the amplifier to live. And so to give you an idea, we've been here about the same amount of time as we were before, and that's what I want to do. We're up to 122 degrees. 122 there. Take a few more measurements other places on the cable. There's 99, 105.
And that's roughly 700 watts less power at this point? 700? Yeah.
Correct. And the key, I mean, that wire is hot. I mean, I wish that we had 4D and you could actually feel the wires. I'm touching it through the screen. This wire is smoking hot. I mean, if I was to keep this running, I actually believe that we would reach a position where the insulation would start getting gummy. We're at 100, and man, I don't know if you can catch that on camera. We're at 132 degrees on that jacket. 132.
Oh, yeah.
132.5. 134. 135. And it's climbing. 136. So I'm going to stop this because that's getting way too hot. But as you can see, the amplifier is still trying to make power. I mean, it's sitting there making 1,600, 1,700 watts, and that's as much as I can get out of that 4-gauge CCA wire. So let's just call it 1,600 watts to be safe. So 1,600 watts is all the power I can get out of 4-gauge CCA, and doing that, the wire is smoking hot. So could I use 4-gauge CCA for an installation? Sure, you can. You can do it all day long. But what would be the safest amplifier to use this 4-gauge CC on? honestly, probably about an 800 watt amplifier, and that's probably about it, and that's probably stretching it. Depends on how long you're going to play that system before that outer jacket's going to get taut to the point that it's dangerous. And so, yes, again, I got to stress, no, we do not recommend 4-gauge wire on a KXA 2400, but this is how we were able to do an extreme stress test and show you the limitations of 4-gauge CCA versus 4-gauge copper. Those 3 plugs you see there are 240 volt plugs each, and then right underneath that you'll see it plugged in. Those are 3 power supplies that we're going to go harken back to the old Warhorse days, and those power supplies we actually had specially built for us so that we could have enough current in-house to actually test the original Warhorse amplifier. And those amplifiers are capable of 300 amps-ish, probably a little bit more than that each. So we're going to be able to turn all 3 of those on. That'll give us 900 plus amps on tap, and then to the side there we've got a couple of kinetic batteries on tap as well. So we have plenty of power, plenty of current here. We can run a whole lot more amplifier than we've got set up here on the test bench. And hopefully, as you can see, pan down a little bit there, showed the resistor load. On the show we did the first one, I think some people saw this sitting under the bench and thought it was an amplifier. This is actually load banks. These are the fixed resistors that we use to test amplifiers with. And this is a special load bank. It's actually on a rolling cart, so we can take it from lab to lab. And with the knife switches that are on top, we can set this up for any type of impedance that we want to have. And right now we've got it set up into 2 ohm operation mode. So this is taking the place of what a speaker would be if this amplifier was hooked up to it. So we don't want a speaker making a bunch of noise. We're just going to play into a fixed load, and that's what this is 2 ohm, very large fixed resistor banks, and that is up here, and that's connected to, sorry, I'm looking at what I'm doing, not the camera, but we've got 2 KXA 2400 amplifiers. And the way we've set this up, because we want to stress 1-aught wire, what we've got is, over here coming off of the power supplies, we have a huge Anderson connector. This is so we can plug and unplug the different wire that we're doing. We come off that Anderson connector into ours. We're going through 20 feet of power and ground, and then we're coming up here to the table, and we've got 2 distribution blocks. The power goes into one, the ground goes into the other, and then it splits out of those with 4 2-foot sections of 100% 1-aught Kicker OFC wire. So out of the distribution block to each amplifier is 2 feet of 1-aught pure copper wire. So the test that you'll see is we have an amp meter set up here, and we have a voltmeter. So we're going to look at amperage and voltage coming up to the distribution blocks, and we're actually feeding 2 KXA 2400 watt amplifiers off of 1 strand of 1-aught wire. Now I will preface this with, no, this is not something you should ever do in your own installation in your own car. If you had a KXA 2400 watt amplifier or an amplifier of equivalent size, you should be feeding that single amplifier with a single strand of 1-aught wire. You should not be doing this at all. But this is how we can stress test the wire, and we can show you the capabilities, the full capabilities of copper versus a CCA wire. So Derek, do you have any questions on that? I mean, obviously you're in the feed there. I see you're down the bottom box.
Yeah, no, this looks good, Kip. Been in that room before. A very impressive power supply set up there. I'm really jealous, and I'm really excited to see what you're going to do here.
I'm excited to see it happen too. Now, I will say, like we said over in the studio, we might smoke an amplifier. And if we do, folks, we're just going to have to move on down the highway and we'll get it repaired, and we'll do this testing again, because this is a very hard test on an amplifier. Just keep that in mind. Now, I do have my phone here. I brought it along with me because what I'm going to use it for is I'm going to use the stopwatch in it, because I do want to keep the test at about 3 minutes, so we got a consistent test. So I've got my stopwatch phone here that I'm going to be using for testing. We have the amplifier set up. You know what we've got for power. We have the meter set up so we can look at current and we can look at voltage. And then we have 2 SMD amplifier. These are the AMM1 meters that will measure wattage output of the amplifier. The reason there's 2 is we have 2 amplifiers, and you'll be able to see right on here the power output of both amplifiers as we ramp up. And then we have a tone generator right here, and this is playing a 50 hertz tone, and it's feeding it into the input of both amplifiers. So I think I've got everything covered here as far as what we've got set up for testing. And so what we're going to do is I'm going to walk around there and I'm going to fire up the power supplies and bring the batteries online. And the first one we've got set up here is we've got the 20-foot power ground of the Kicker 1/0 cable that we're going to test first. And then, so I'll turn the amplifiers on, I'll turn the power supplies on, I'll come back around here, the amplifiers will turn on when the power supply comes on, and then I'll start ramping up the tone generator, and we'll let this test run. And what we're going to look at is power output, we can see current draw, and then we also have our trusty measurement device here. This is one of those handheld infrared contactless readers, and so we can measure temperature of the amplifier, and more importantly, we can look at temperature of the cable. So does this look Big D approved?
I approve. Only thing we're missing is the FLIR, but we'll get that for next time.
You know what's funny about that? They have a FLIR up in the lab, and I should have borrowed it, and I didn't. So I apologize for that.
Again, we got to leave them a little bit for next time, Kip. Can't give them everything this time, right?
Okay, I'm with you on that. But we, obviously the stuff that you do with your FLIR, I think is pretty impressive, showing all that different temperature and where things get hot and where they don't. I think that's pretty cool. Okay, so power supplies are on. Batteries are online. You should see the amplifiers powered up. Power. Oh, I'm not plugged in. Where am I plugged in? Okay, I'm plugged in. For some reason I'm not getting a reading here. Let me see. Oh, it's because it's on AC. Duh. That's why. There we go. Okay, so you gotta make sure you put the fluke in the right position. So I'm off camera here, and hopefully you guys can see. So we've got, right now, if you look at this meter right here at the far left, this fluke, the way this works, this is a clamp probe that's on here, and it reads into here, so that means it's pulling 3 amps of current right now. And so you'll be able to see the actual current draw through the wire. It'll count up here on this display. This is the voltage coming in. This is the power output of each amplifier, and I'm going to start ramping up the signal, so here we go.
Kip, let me know when you want me to start the stopwatch, because I'll start mine too.
Are you go? Okay, good. I'm ramping up power now, so I'm going to go ahead and start mine. The meter's turned off. We turn them back on. Unfortunately, hold on a second. Okay, real-time power. There we go. So as you can see right now, there's 536 watts coming out of the KXA 2400 on the left, and there's 532 watts coming out of the KXA on the right. So we're pretty close there as far as having these gain match. That's pretty good. So I'm going to start ramping up. Okay, there's 2,389 watts out of the one on the left, 2,433. I'm going to go up a little bit more.
That's that squeaky sound I was talking about.
There you go. Okay, so 24. Okay, there's clip. So I'm going to back it down just a little bit and leave it there. So we've got 2,400, and it's varied between 2,390, 2,427. Of course, it's going to bounce around. On the amp on the left, we got 2,460, 2,497, bouncing around the right. So hopefully you can see the test running. I know we got a little slow start there, so my stopwatch is not completely accurate. We'll give it another 30 seconds, but I've been 1:20 on that test. And if you can see, both amplifiers are still made, and we're going to understand, this is going over one piece of 1/0 wire. And if you remember that chart we showed in the room there, we are well beyond the spec, because if you look at current draw right here, we're pulling 512 amps of current through that wire. 512, 513. And so to give you an idea on temperature, we're at, I got 1:44. You may have a little bit less than I do there, Derek. I'm going to do a temperature test back here. So on the power wire here, I'll show it to the camera, we're at 78 degrees. I don't know if Tim can get that full into view, but the power wire right now, we're at 78 degrees. So really room temperature. I mean, we're not, so there, we're at 80 degrees right now. I'll pull up here a little quick. So right now we're at 80 degrees. We're still 2,500 watts out of the amp on the right, 2,460, 2,470 out of the amp on the left. I've got 227 on my timer. What do you got there, Derek?
Yeah, I'm right at it. We're right at the same time.
Okay, I'm gonna let it keep going. I do want to do a full 3-minute test here. Okay, so here we're up to 106 as far as temp on the wire. I'm at 106 right now. and we are still making 2,550 watts here. We're making 2,470, 2,500, 2,480. We're still making full output power from the amplifiers. As far as amplifier temperature, one on the right, we're up to 139 degrees. And I'm just showing that it's really, we're talking about the wire, but I figured you guys would like to see the amplifier. Amplifier on the left, we're at 140 degrees. And we're pulling 533 amps of current on the amp meter you can see here. And you'll notice the voltage has dropped down to 12.82. What you're seeing happen right here is as the voltage is dropping because the wire is getting hot. And because the wire is getting hot, the amplifiers, these are semi-regulated amplifiers, they're going to start pulling more current in an effort to keep making that full power. So you notice we started a little over 500 amps, now we're up to 534 amps because our voltage has dropped to 12.78. We're at 3 minutes and 47 seconds according to my timer. I'm going to come back here and check the wire again. Yes.
Yeah, you're solid 3 minutes, Kip.
Okay. You hear me okay? Did I lose you?
No, I'm here.
Okay.
Yeah, I'm just saying you've got a solid 3 minutes of the amp at full volume.
So I'm going to bring that down now. Yeah, because I'm at 410 on mine. I know we got a slow start, so I'm going to pull that down. Because I do want to give the amplifiers a second to cool here. Maybe we can answer some questions or look at some stuff. But that was definitely a solid 3 minute plus run right there of making full power out of these amplifiers. And I'm going to come around here to the cable. And the cable is, I mean, it's warm. I mean, I'm not going to lie, the cable's warm. So I don't know if you can see that. The cable, I'm at 138.5 degrees on that cable. Okay. So here's where we're at. Turn this off, get this going. So here's our amp meter. Here's our voltage. We've got our clamp on. We got our 2 SMD meters up ready to read power. So are you ready to start your timer?
I'm ready. You tell me when.
Okay, I'm going to start climbing power now, so go. Okay, we're at 1,300 watts on the left, 1,300 watts on the right. Okay, I don't know if you just noticed, but both amplifiers just shut off. Did you see it?
Yep, sure did.
Okay, I'm gonna turn them down a little bit so we can get there, so they'll stay on. So I'm at 1,850 watts on the left. I'm at 1,850-ish watts. It's bouncing back and forth like they do. I'm at 13 volts, and you can see I'm pulling 365 amps of current. So you noticed over the 1-aught copper, we were able to pull 530 plus amps of current through it. It powered the amplifiers, and yes, it was getting warm, but it let both amplifiers make full power. I'm here. I'm going to see if I can go up one more click. Okay, so there I'm at 1,900 on the right. I'm at almost 2,000, 1,980. There's 2,000. There's 19 some change. So I'm at 2,000 watts per amplifier. I'm drawing 429 amps through the wire. I'm down to 12.3 volts. And I'm just going to go ahead, just out of curiosity, I'm going to take a reading back here. Okay, it's getting warm. I'll see if I can get any more power out of the amplifiers. Shuts right off, so I'm gonna back it down one click. Let them kick back over.
Do those come out of protection automatically, Kip, or do you have to power cycle
Yes.
them?
They should come out of protection automatically, unless the only time on these is it is possible on the KX line, because it's a DSP chip, is sometimes you do have to remove power and bring them back if they're into a funky shutdown protection mode, which they might be right now. That's why I'm looking here. I'm just going to roll see if they'll come back. Okay, there we go. I got them to come back when I remove signal completely. So
I think the one on the left is still in protect. Oh, there it goes.
it started pulling so much current, it actually put one of my power supplies into protect out of the power supply. So I'm going to reset it. There we go. There we go. There we go. Okay, so we're back. So this funky stuff you see happening, you notice it didn't happen when we were using copper. Which kind of ties back to the same thing we talked about on the show previously, is a lot of times when we have people call in and speak to our amp repair department or have a warranty issue on their amplifier, there's the majority of the times we chase it down, it's a wire issue, it's a power supply issue, because a lot of people are running CCA wire. And the worst part is, they're like, okay, well, yeah, you said I need 1/0, but I can use 4-gauge, and I can get 4-gauge CCA, and man, I'll be great. And so you're literally starving the amplifier for current and putting it into situations where it shuts down. So now I got the power supplies back, I'll ramp this back up. So here we are, I'll get up to okay. I'm at 2,000 watts in amplifier.
Yeah, I started mine over, Kip.
Oh, thank you, yes. Thank you for doing that. I appreciate that, man. So, and I'm going to try that. I know you may not be able to see it on this scope I'm using, but I'm at 2.6. That's how much voltage I'm driving to the input of the amplifiers. And if I go to 2.7, they'll shut off. So what I'm going to do, I'm going to come over here and see if I can bring it up a little bit. So I'm going to go to 2.61. There's 2.65. And you can see we're down to 11. We're already 11.8 volts. I mean, we're pulling 472 amps of current through the wire, and we're down to 11.8 volts. Both amplifiers are making right at 2,060 watts. And the power supplies just went into protection. So I'm going to ramp this down again. Reset the power supplies.
So I guess what we're saying here is it's difficult to to do comparison testing because we're not able to get the same amount of power or the amount of current through the CCA wire.
Correct, but I'm gonna give it my best effort here. We're gonna do it again. So we're up and running. I'm gonna run this up. Go back up to 2.6, and there, click, just shut. I'm gonna turn down a little bit. Okay, hit my start. So we haven't even been able to get a full 3-minute run out of these amplifiers at full power, much less anything else.
Do me a favor, ramp the voltage back down and then back up and watch the 2 outdated wires in front of your power supplies.
Over there?
Yes.
Okay, here. Can you see that? Are you on it?
Yep.
All right, so what Tim wants you to see there, guys, is I've actually got the input to the amplifiers turned down. Watch as I ramp this back up. Look at what happens to those power wires. Are you ready? You see them moving? See them spread apart and they're moving?
Poltergeist.
And it's getting hot now.
I think Kip, I think y'all's internet is probably breaking up just a little bit. Your quality has dropped a little bit on the camera. We can still see it, but it's a little bit pixelated.
Okay, hopefully it picks back up here. We did notice earlier in the show that we were getting poor connection quality to StreamYard. But here, I mean, we're not making full power, and right now we're at 132 degrees on the wire. So hopefully you can see that on the temperature meter there. It is running. We're making, I got to turn this one back on. Unfortunately, it timed out. So on the amp on the left, we're making 1997. It timed out too. I need to turn it back on. Yeah, that is the one thing. It's funny you mentioned that. I'd love to talk to Steve about getting some kind of a hold function on these so they will just stay in a mode. And then, if the battery goes dead, at least you're responsible for that. Okay,
Yeah, somebody in the comments said that the CCA is connecting to the Wi-Fi also.
We're powering the Wi-Fi over CCA. That's awesome. Okay, so to give you an idea, here's where we're at temperature-wise on that wire. We're up to 160 degrees. Can you see that?
Yep.
Okay, we're making we're making 2,000 watts on the left, and the amplifier on the right has actually went in to protect. So it got current starved and probably shut down. I'm going to turn it down one more time. See, that test ran, on my stopwatch, I got up to 2 minutes and 40 seconds there. I don't know if you had something run on your end.
Yeah, I'm up to 350 now, so.
Okay, so 350. So, here's where we're at. Wire is a component. You cannot run an amplifier, you cannot connect to a speaker, you cannot connect to a head unit without the right wire connections. And to call it an accessory almost implies it's an add-on like jewelry. Proper wire and connections is not an add-on in like jewelry. It's a component, just like your woofer, just like your speakers, just like your amplifier, just like your head unit, just like your crossovers, your EQs. Proper wire is a component. And you really need to take that in consideration when you're designing your system. And I know what it's like, guys. I wasn't always at the point where, I had a little extra money to go out and buy what I wanted. I mean, I had to save and save and save, paycheck after paycheck just to get to the point like, yeah, there's that shiny amp I want. But you got to always remember, put a buffer in there and know that you got to buy the right wire to go along with it. And I think a lot of guys, they get disappointed. They get that first-time buyer's remorse, and they start having problems because they buy the right gear that they want, and then they end up hooking it up with inferior sized or inferior capability wire, and they get that, man, is that the best I can do? Oh, it's shutting off. Why is it doing that? They get that buyer's remorse. That's why we're here to tell you this stuff, guys. We don't want you to experience that, and we see it every day on phone calls. And like I said, I'm probably being even a little lean when I say 9 out of 10. Most problems that come in where it's repeated problems like that or random issues, it all boils down to wire connectivity, the wrong size, voltage drop, things like that, poor ground. Those are really the issues. And as you can see, we're just showing you here that in the wire selection, the amount of voltage drop you can get in one material versus another and what it means into real world performance. So hopefully you guys find it interesting enough that you like the video, you think it's informative, and you come back for more stuff.
Okay, David, what did I say? What did I say? I told you that when Kicker does something, they go all out. And what did I get from this video? It shows me that Kicker is a brand that cares, and not only cares about their product, but cares that the people who are purchasing the product fully understand what it is they're getting into. That's my takeaway. What do you have to say, Dave?
I agree 100%. Kicker, this is not a new message for Kicker. They've been preaching this for a number of years. And, when they do the CMA show and CES, one of my favorite things to do is take people to a display or fixture that they had there where they had an amplifier mounted, connected to CCA and copper, and by flicking a switch, you were able to see how much power that amplifier made using the CCA wire and the copper wire. And it was a difference of 100 watts. And, it's one of the most exciting things for anybody to see real time, what a difference that quality of wire makes. I think it's one of the coolest things that Kicker's ever done, and I'm glad that they continue to promote this message.
You bring up that display, and I just have to tell you, Dave, that was really the inspiration for us to do these other two demos that we've got with 4-gauge and with 1/0. And the display, and it's here in the studio. We've actually, if you go find the Science of Wire Part 1 at the Kicker Unmasked Live on our Kicker YouTube page, you can actually see that 8-gauge display that Dave's talking about. We actually do a demo of that in Part 1. But we really wanted to focus on the meat and potatoes, the bigger wire. People ask us all the time, yeah, I see it's with 8-gauge and blah, 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 but is it really going to be that big of a difference with 4-gauge, or is it going to be that big of a difference with 1/0? And as you can see from the demos we just did, when it comes to the 4-gauge, we can't even get the KXA 2400 watt amplifier to full power reliably, whereas the copper does it all day long and has no problem. And you can see the temperature difference. I mean, the OFC wire runs significantly cooler than the CCA. And if you're using undersized CCA in that condition, let's just say, for example, you're looking at that amplifier and going, yeah, I could use smaller wire, and you're using CCA, the heat even goes up more the amps starve for more current. And I'm not trying to do fear selling here, but if you guys aren't using the right size wire and the right technology for that application, you can get into a hazardous situation and cause a fire in a car. And that's not fear selling, that's just a fact. And these demos kind of lead down that path. And then with the 1-aught, you can see we actually tried to power two 2400s, and you could definitely see the problems we had with the CCA. It couldn't even keep the amplifiers operating reliably, whereas that one strand of copper got it done. Would never recommend you run one strand of 1-aught copper to run two 2400 watt amplifiers that size, but we were using those demos to stress that wire to show you the actual limitations and what you're buying for your money. And you're losing performance across the board. And Dave, I'm glad you brought that up, because why put all your money into a 400 watt amplifier when simply changing the wire from copper to a CCA wire, you lose 100 watts of power? If that's the case, why didn't you just buy a 300 watt amplifier and get you some copper wire?
Dare I say, and this is going to be for the record, that you are arguably sabotaging your customer by not, putting the right gauge wire, the right quality wire in a system when you're selling them.
You know, it all goes back to that principle that wiring is not an accessory. Wiring is a prime component that you need to create an audio system, whether that audio system is just a bass amplifier and subwoofers or upgraded speakers, full range amplifiers, a sub. No matter what you're doing, wiring is a component. And I know how it is, because all of us are the same. We want to get the best value for our money, and people just look at, that's 4-gauge wire and it's $4 a foot, and here's 4-gauge wire and it's $1 a foot. Well, I'm going to say $3 a foot. They don't even ask the questions about, well, what technology, what's the science, what's in that wire, and what am I giving up or not getting, and they don't know. So we're trying to educate people to ask the questions. I love for people to buy Kicker wire. It's great wire, it's very flexible, it's 100% copper, it's tin plated, it is made to be durable and reliable. But at the end of the day, I make this statement even though I'm here for Kicker. If you can't afford Kicker wire, we make great wire. Love to see you use it. But if you can't, do yourself a favor and just go find the best priced 100% copper, true American wire gauge you can find, and no matter what system you're putting in, you're going to be not cheating yourself and getting the best performance out of your system. And that's the real message. We want you to get everything you paid for.
Great message. I should round out before we let you go, Kip. We're talking a lot about power wire, but Kicker offers a full range of wiring solutions, including interconnects, including multi-strand wire, distribution blocks, etc. Dave, I know I must have missed something, but all available at Gemsen, right?
Yeah, we carry it all, we support it all, and continue to add more SKUs to the lineup. I mean, there's a whole selection of marine-only cables as well, right? So they
color-coded marine too, if I'm not mistaken.
Yeah, there's a different protocol, and Kicker offers those type of solutions too. So we've got them all.
What can I say? We need Kip back more often, Dave. Can you make that happen? I always want Kip and the Kicker team here. This is great.
Well,
I'll go ahead and chime in for you, Dave. Anytime you want to get us on the show, just give us a schedule, give us a heads up, so we've got a few days to get ready. We love coming on CMA. We love talking to Dave. We love talking to you, Ben, and being able to share the knowledge and the information with the consumers. That's what it's all about.
Cheers to that. Cheers
Appreciate it, guys. Thank you
so
much.
Have a good week, and enjoy your time at the Country Festival, sir.
Will do.
Take care now.
Have a good one.
Bye-bye. Yeah, I can't say enough about that. Love having Kip on. But you know what? This one I really appreciate, because the amount of effort that this company has taken to educate consumers, dealers, installers about how important this is, I got to give them props. I mean, not everybody has done that. Not every brand has gone out of their way to do that. So, yeah.
Well,
high five to Kicker.
I agree. And, it's also in their best interest, because starving the amplifier is going to reduce the lifespan of that product. Heat is the number one enemy to any electronics product, and as you saw in those demos, when heat starts to get generated, it's bad news, and you're going to see amplifiers break prematurely, and you're spending a lot of money. You want to get the most out of that amplifier, so using the right stuff is so important.
Dave, another good one in the bag. Put this one into the showcase. Learn about wire. Think about Kicker. Give Gemsen a call. Thanks so much, Dave. We'll talk to you soon.
Thanks, Ben. Appreciate it.
There you have it. Some wiring science and getting our learn on, from courtesy of the boys at Kicker and Gemsen Distribution. Thanks for tuning in to yet another lunchtime learning session here on CMA Connected, presented by SiriusXM. Until the next time, we connect.